Good morning, good afternoon, and good evening, everyone. Welcome to the first session of the Machine and Deep Learning in Oil and Gas Industry event. Hope you are doing well and staying safe. My name is Mohammed Zakaria from the organization committee in SB Al-Azhar, and I'll be the moderator for this event. Today's session will be presented to us by Engineer Emad Elgebesy. Before I remind you of the rules, I would like to welcome special guests who are attending with us today. Dr. Tariq Abul Futuh, the supervisor of SB Al-Azhar student chapter, and Dr. Muhammad Al-Haggar, process EGM at Petrogulf Company. And now I would like to remind you that if you have any questions, you can drop them in the chat box below. And if you want to speak with an instructor, you can click on the raise hand button and we will unmute the microphone for you. And finally, we will send an attendance and feedback form in the chat box. Make sure to fill it. And now let's begin. Dr. Tariq, the mic is yours.
Good evening, ladies and gentlemen. Today we have the first session in machine and deep learning in oil and gas industry with Excellency Engineer Emad Elgebesy, the founder of Optimized Global Solution Company. Excellency Engineer Emad Elgebesy, you can go ahead for your session.
Thanks a lot, Dr. Tariq, for this introduction, and thanks, Mohammed, from SPE Al-Azhar chapter. And before starting, I would like to thank SPE for giving me this opportunity and platform to talk today about machine learning and deep learning application in oil and gas industry and energy sector in general. Do I have an option to share my screen?
Yes.
Okay, thanks. So today we will launch our first session. My intention today is to basically to talk about the basics. To understand any new concept or any new subject, we need to know what are the basics, what are the foundation of that one. And then we can go to practical application, where the practical application will give us the right deep knowledge to see how to use this stuff. When we talk about machine learning, I hope after these discussions today, we will answer many questions. What about machine learning? Why machine learning? And how to implement machine learning or deep learning projects. So in brief, our table of content, we will talk about the team, and this is already done, introduction. And then we will move to some basic definitions, industrial maturity overview, and AI look ahead, machine learning framework, AI acquired benefits, SelectMB, and AI concept. And eventually we will talk about AI business opportunities and growth. First definition we will talk about is AI. AI is the most common used and abused term in industry. And most of you hear about AI in industry. So AI is a broad.
Sorry for interrupting you, Engineer Ahmad, but we can't see the presentation.
Okay, you can't see the presentation. Okay, let me. Okay, thanks. So thanks, ladies and gentlemen, for your patience and waiting. We can now resume our today's session. Today's session is the first session of a long series of where we have an intention to introduce machine learning and deep learning application based on real cases. Today, our key objective is to answer some questions. What is machine learning and deep learning? Why to use this? How to complete and execute complete project of machine learning and deep learning? And to answer all these questions, in the first place, we need to understand this new domain and what are the foundation, structure, and basis of that, and what are the associated definitions, and how we can monetize machine learning and deep learning as a project and to get value from it. So hopefully this is the key objective and the scope of today's session. And the second, third, and fourth session, we will be focusing on real cases from industry, and we will go through thoroughly the key steps of completing an artificial intelligence projects. Next slide, please. So in that slide, we will talk about just one by one. Let's just focus on AI. No need to display machine learning and deep learning. AI is the most common used and abused term in industry. All of us, we are hearing and listening about AI, but what is AI in principle? In principle, it is a broad term. It is a generic term. It includes software development. It includes machine learning. It includes deep learning. So when we talk about AI, we mean to say if this is an AI project, it may include some machine learning application. It may include some deep learning applications. So this is the key definition and the meaning of artificial intelligence. Next. Machine learning, it is a subdomain from AI, and basically in the machine learning project, we have big data, and this data, simply to simplify the concept, it is X and Y. We have input and we have output. So the key function of machine learning is to study the relationship between the X and Y via feature engineering and some other techniques to eventually found fit for purpose empirical correlation between input and output. And this empirical correlation, it can give you a very accurate prediction of your Y, providing your input to this X. And this X can be temperature reading in the field. It can be a pressure reading, level reading. And this Y can be determined based on the key performance indicators and your key objective from that project. And we will learn how to define the KPI in the subsequent slide. Go to next, please. Deep learning. It is the same approach like machine learning. It is a study, and we seek to find relationship between X and Y, but using the artificial neural network. And it is entirely different technique. In machine learning, it is all about the statistics. It is all about mathematics. In deep learning, we talk about artificial neural network. So this technique, or the new engine in the deep learning, it will do the same function like machine learning to eventually find fit for purpose empirical correlation to link X and Y. Next, please. Data science. Data science, it is a big domain, and any deep learning or machine learning study, it has to be preceded with data science. And in data science, we study the data we have. We visualize the data. We understand what is the pattern between X and Y, and what kind of relationship is that data provided. Is it clean data or unclean data, healthy or unhealthy? Do I need to remove outliers? Do I have some noise? How to remove the noise? How to understand the influence between various input and various output? Because that part will determine the accuracy, the measurement of accuracy and measurement of predictability of your AI projects. Next, please. This slide, it is more philosophical. It is not a definite guideline for the industry of oil and gas, or how we perceive the machine learning. It is simply based on long years of experience in oil and gas, and we can call it the level of excellence in operating company, or the level of maturity in operating company. When we talk about level 1, you can find some operating companies in oil and gas, and they rely on the first principles. And first principles, it is basically the heat material balance we have studied in universities, how to do heat material balance, how to solve thermodynamics, how to predict the physical properties of heat exchanger, how to predict outlet temperature of heat exchanger. Some operating company, they are adjusted to that level, and they do not go above this level. So their operational excellence, it is bound to level number 1, where they have a specific simulation for a specific unit operation, not the entire unit operation. And we call this level 1. These kind of levels, it is defined with an objective to identify the level of competency of each operating company. So as a consultant, if I need to diagnose the room of improvement of any operating company, I need to relate that operating company standard to that level of maturity, so we can provide a good proposal and good solution for that corporate. Next, please. So here, when we go to level 2, which is an advanced level compared to level 1, going one level up, we will talk about some advanced features like energy optimization, how to integrate the process with the utilities, how to save my fuel gas consumption, how to save the steam consumption, and how to save also the brake horsepower of a specific pump or a compressor. Next. And also associated with level 2, we can see the dynamic modeling, dynamic simulation. It is very important if I need to increase the level of rigor in my analysis, I can include dynamic analysis to gain some insights within my operating facilities, considering the real-time data to understand my performance. Note to mention, in level 1 and level 2, level 1 can adopt machine learning, not because it is a lower level of maturity, cannot apply and cannot deploy the machine learning. It can use machine learning. And also for level 2. Level 1 and level 2, they can be advanced and leveled up to level 3, which is the industrial machine learning based and artificial neural network solution. We can use some of the data from level 1 and level 2 to enhance and to advance our industrial AI within the corporate. What is the key objective? Now, one of our questions today, as agreed, it is why we need machine learning. Basically, machine learning, it became very essential tool for executives and C-level in operating company when they need to make a very quick decision and accurate decision. They can use data-based solutions such as machine learning to get an answer, and this answer, it will help them to invest very quickly. The longer the time you will take to make a decision, it is actually the longer the time you will get the payback within your revenue. So this is the key an advantage of machine learning. It helps C-level and CEO and executive within the operating companies to make very quick and accurate decision to decide to go with this investment or not. Do I need to increase the production on that unit? Does my unit operation is capable to withstand the capacity increase or not? Level 1 and level 2, definitely it can do that. First principles, steady state simulation, dynamic simulation can answer this, but it is all about the time. The longer the time you will take to come up with a conclusion, it is actually the less revenue will go back into your pocket. In addition to that, level 1 and level 2, it needs a special expertise. People from domain knowledge, process engineer, chemical engineer with well-experienced capability in a steady state simulation and dynamic simulation to identify the problem and to resolve the problem, which is not exactly the case in machine learning. Machine learning, it is very high level. It is basically and intimately bound up with the data from the field and getting the data. We are turning the data into profit. We are cleaning the data, reconditioning the data to eventually come up with AI inference, and this inference will answer so many questions. Next, please. Next. So in the next session, we will have more exposure to the SelexMB, which is one of the industrial machine learning application in industry and being used in Middle East with many renowned operator. And the concept of the industrial machine learning software, it is actually, as you can see, on that right hand side we have a nice figure, and that figure, it shows us the data science as a domain, software application as a domain, and process engineering or hydrocarbon processing as a domain. Simply, if you need to have an industrial AI, very focused and a specialist software, you need to have your application in that overlap between the three domains. So you need to have a good combination as a squad from software experience and AI and data science experience with people from our domain knowledge, which is oil and gas. And those teams, they need to work jointly to collaborate in a specific project, and they can use that application and they can execute any project. So the any recipe of success to do a machine learning project, you need to have the domain knowledge from oil and gas, and you need to have people from software experience and data science experience. If you don't have software experience and AI and data science experience, in that case, you need to have a software, and the software actually will be embedded with the good packages of data science and data cleaning, machine learning, and deep learning in a very simple visualized form to allow you and to empower you as an engineer or manager from oil and gas to execute your project. So this is the key difference between the industrial AI, which is a specialist software. It actually does the role of the data science domain and software domain to facilitate your function. The conventional approach, and people used to work until this time, but most of these projects are not successful, is to have three key teams: a team from software, team from data science and AI, and team from oil and gas industry, process and chemical engineer, and they work together. Sometimes there is no harmony and synergy between those three teams because they have never done any similar projects before. And also, the one of the key advantage to use a specialist software in industry, it is generic advice. It is not only about machine learning. If we talk about mechanical engineering, civil engineering, chemical engineering, the commercial software, it will help you to lower the barrier to adoption. This is a new area, and you need to invest more time and more effort in machine learning because you think deeply and profoundly there is a need to apply AI in your operating company. This is a barrier, but you have the willing to adopt. We are helping you to lower the barrier and to get over the barrier by using commercial validated software. So this is one advantage. The second advantage is to overcome the lack of skills. And this is attributed to the conventional approach. Conventional approach, people are working with Python, people are working with software development, they do a desktop application or SaaS application, and you have a third team coming from the oil and gas. Sometimes you have lack of skills within the domain and lack of skills within all domains, which is presented in the communication. So any failure, any deficit in any kind of communication within the domain and among domains, this project will fail. And the third advantage, and in my opinion, this is the most critical and paramount one, is actually it will accelerate the return of investment. Because we need to agree machine learning, deep learning, or any data-based solution, actually the way it is executed and the agility where you execute, it is much faster compared to the first principles we do at the moment. Next. This is, we need to take this slowly, please, admin. So go back, please. Just I need to talk about, yes, we have plant data. In that slide, this is very important slide. And my advice for everyone of our attendees, we need to understand this framework very thoroughly and very profoundly. And if you have any question, you need to interrupt me and to ask. Your understanding and comprehension of that slide, it will help you in the next and third and fourth session. We can execute many machine learning projects together. So our framework to have any data-driven project, you need to have a data from the plant. So this is first step. You have a plant and you have a system, and this system in industry, we call it DCS or historian. And from the historian, you can get reading of your tags for 1 month, 2 months, 1 quarter, 2 quarters, or for 1 year. So this is the key input to the framework of machine learning and deep learning. Next. Some application, and also we will see that we can get the data from first principles. This first principle simply, it can be any database in the book. We talk about reliability data, probability of failure on demand data from ORIDA handbook, from ISA, a specific calculation, and from this calculation, which is first principles based, I can generate data, and this data can go directly to the machine learning, or it can go back to back with the data from the plant to the machine learning. So here, what I'm trying to say is, as a framework, as a key input to that framework of AI, we can have data from the plant, we can get data from first principles, we can have synergy and mix between plant data and first principles, and we call this hybrid modeling or hybrid paradigm. So this hybrid paradigm, some cases, the plant data is not well thought, it is not complete, and we need to bridge this deficit from the first principles. And this is for some very critical case for the flow assurance, and this will be one of our practical example we will discuss in the next session, and we will practice together in the next session. So to conclude, the key input to the AI framework, we need to get data from the plant, and we need to get data from the first principles. It can be and, it can be or. Next. And then those two inputs, they will go to the AI SaaS application. And we agreed this industrial AI, actually, it embeds the 3 domains. It's there is synergy between the data science and software and the data from oil and gas. All these attributes are already embedded in SelexMB. Next. So as a SelexMB, now we will start to practice the key steps to complete a machine learning or deep learning project. First thing any AI project needs is to upload the data. The data you got from the plant or the data you got from the first principles, you need to upload. Next. After that, we talk about key performance definition. I need to stress about the key performance definition. So many underlines, more than 100 underlines, and you need to keep this in your mind. Key performance definition is very crucial to the success of machine learning. If you fail to identify the key performance definition, your machine learning project, your deep learning project will screw up. If you have the right domain knowledge and you have thorough understanding of the operating facilities, and you define the KPI of your system in a very right way, 99.9% the execution of your AI project, it will be up to scale. Third step, which is actually the data conditioning and feature engineering, which is very essential step. You need to rehabilitate the data. And this rehabilitation, the data we get from the field, it is not clean data. It has so many noises from the instrument transmitters. It may have some outliers. And also, in addition to the data conditioning, we do feature engineering. Feature engineering is very important. To simplify this concept, I can give a quick example. If we talk about separator, and the separated gas from separator, actually, it depends heavily on the operating pressure inside that separator, on the operating temperature inside that separator, and also on the inlet total flow to that separator, the amount of gas in, the amount of condensate, and the amount of water. So this is generic. And I will get this data from the plant. But when I do feature engineering, I can see there is very small impact between the water inlet to that separator and the amount of gas separated. Because basically water, we know from the first principles, It is not soluble in the hydrocarbon, and water in, water out, it will be separated very easily, and there is no much of influence from the water on the gas flow rate. But what really empowering and significantly influencing the gas production from that separator, the inlet gas amount, the condensate gas amount, you might have some gas flashing inside separator, so this will impact the gas outlet. Any change in operating pressure and temperature, it will impact the amount of gas produced. Feature engineering, if you don't have this kind of operational experience, but you have good data, feature engineering, it will tell you, keep in mind the amount of water, it proportionate directly with the amount of gas, but the order of magnitude, it is 0.01. You can exclude the water from your analysis to avoid overfitting or underfitting. This is very, very important, feature engineering. And we will talk about feature engineering in details in the subsequent slide. But as a skill, it is really needed within the execution of any machine learning project. After that, once we define the key performance of the system and we clean the data and we identify the influence between the independent and dependent, then we can go to the model build. I need to build, to make a framework, to make a fingerprint of that AI model. Is it going to be solved by machine learning? Is it going to be solved by deep learning? Is it time forecasting problem? Is it classification problem? Is it regression problem? There are so many techniques underneath the AI model building. And the software, it includes all these techniques. It is all about you to determine which algorithm, which method you need to identify for your problem. Is it a prediction problem? Is it forecasting problem? Is it time related? Is it process variable related? Is it classification? Do I need to conclude slug, no slug, hydrate, no hydrate? This kind of classification, it is entirely different from the prediction. So one of the input to the AI model building, it is you, based on your objective, what is the objective of your project and what kind of outcome you need to fulfill. So one of the pillars underneath AI model building, we have MLOps, stand for machine learning operation. And under machine learning operation, we have so many algorithms. And again, briefly, we will go through all these algorithms in the next session when we start to practice real cases. But it is worthwhile for you to understand the framework and what kind of AI model building in the application. So MLOps, it is machine learning operation where you can have supervised machine learning algorithm, unsupervised machine learning algorithms, regressions, linear regression, polynomial regression, some random forest, Elgebesy. There are so many algorithms in that area. Deep learning, it is the same concept, but we use the artificial neural network where we use the different techniques, but the outcome from that different technique, it will eventually create relation between X and Y. Time forecasting, it is a solution in AI, and one of the application of time forecasting is to have predictive maintenance. I need to predict the performance of my operating facilities with respect to the time. So in the next 5 weeks, what would be the performance of the vibration reading of my pump, temperature reading of my pumps, exchanger temperature targets as an indication of the fouling progression within that exchanger. And based on the forecasting from that time series, I can say in that week number 2, in month of September, year 22, I need to have a planned shutdown for my exchanger to do a cleaning. So the benefit from this planned shutdown as a predictive maintenance, you are prepared for this shutdown, which means the downtime will be much less, considering as if it is an instantaneous shutdown, you would not well prepared. It will take you longer time to fix this problem. The key value and the value proposition we are getting as an engineer, as a managers for any operating facilities, when you convert and when you move from the unplanned downtime to planned downtime, your revenue will be much high. because planned downtime is associated with lesser time compared to the unplanned downtime. Classification is one of the techniques in AI concept, and basically this is yes or no, binary system, slug, no slug, hydrate, no hydrate. People will die, people will survive from this event. And also it has so many applications in the upstream flow assurance and the process safety and functional safety. Next, please. And then the second last step, I have done already my selection. I selected the algorithm, which is deemed essential from my perspective, but I need to validate my selection. If this is the right algorithm to be used or not. We have some statistical parameters qualify my selection. We call it R-square, root square, mean error, the confusion matrix, and based on the outcome from these statistical parameter, we can qualify, disqualify this algorithm, and then to go to another algorithm if my statistical parameter is not in my favor. Next, please. And then after that, once I have got and concluded my validation within the satisfactory range, I can deploy the model. And eventually the model, as you can see, it will be very simple, depicting all input where you have defined in the stage of the key performance definition. And this input, by the way, we have two options in our SaaS application. It can be offline and it can be online. If it is connected to the commercial software in industry, such as HISys, Unisim, other software, it can be online. If you prefer to be offline, you can provide it as an input, such as what if scenario or ad hoc basis. And based on the input you will provide, the model will predict the outcome. And this outcome, again, it depends on your definition of the KPI. So I'm really willing to take any question on that slide before proceeding to the next slide, because for me, this slide is very crucial, the artificial intelligence framework. Can you go back, admin, please, to the previous slide? And let's take some question on that one.
Okay, please, Engineer Ahmed, my question, can we use all the AI model in the same time, or I must select one?
What do you mean? You mean under AI model building, machine learning, deep learning, time forecasting,
Yes,
classification?
yes. Can I integrate between them in the same time?
It is a good question. Uh, you can have classification with machine learning. Imagine you have got data from your plant, and you supplemented this data with some first principles such as hydrate temperature. So this hydrate temperature, eventually it will conclude in your data hydrate or no hydrate. So now you have a classification. You need to predict some parameter from your data and to have binary classification. Do I have hydrate if I increase the gas production? If the black startup at this temperature would result in hydrate or not? So the application allow you to combine classification with MLOps or to combine classification with deep learning. So you can have this mix. Time forecasting, it is a standalone objective. We have never seen in industry as a time forecasting, you need to have a process variable, you need to have a prediction based on the process variable. So time forecasting, it is a standalone and you cannot use it with any other concept like MLOps or deep learning or classification. Classification can be used with first and second. You can make a good mix combination. Time forecasting is a standalone.
Okay, thank you. With reference to AI validation, is this parameter default for all the model, or can I use another parameter?
It is a statistical parameter. It is like the check if we do flare assessment, I need to check the back pressure, Mach number of square, right? So these confirmation or these checks, it is by the code, it is compulsory. We are compliant to apply this. So the same concept applies here. For the AI validation, because it is a statistics, R square, Q square, it is applicable for ML ops, for deep learning, for time forecasting, and also root square mean error. This is very important. In some cases, R square is not that big. It is 70%, but I can accept it if based on my interpretation for the root square mean error. If we talk about temperature, I can accept one temperature difference. If my actual data is 60 and my prediction is 61, for me, this is very close prediction. But eventually it is 1. Root square mean error as a 1, it may result in very low R square. So this is how we read the statistical parameter. But all what I'm trying to say, R square, Q square, root square mean error, it is actually bound to the machine learning, deep learning, time forecasting, confusion matrix. It is for the classification.
Okay, thank you.
Any other question before moving to the next slide?
Okay, Engineer Ahmed, we have two questions in the chat box. First question said, how can I get a demo or real data to do data analysis and AI on it?
How to get a demo?
How can I get a demo?
If I understood this question correctly, the next sessions we will practice together real cases, and in this real cases it is a kind of demonstration of real cases. So we have some data from previous projects, and this is what I will use in the next sessions, if I understood the question right.
Okay,
So today's session is not meant for practicing, because we cannot have so many things in one day. It is very heavy weight subject, and I wanted just to nail down the basis and to give them real understanding and very simple understanding of what does it mean by machine learning, and then from next session we can practice.
Okay, second question, are this can use it in reservoir engineering?
Yeah, absolutely. One of my ongoing projects with, without mentioning the name, it is in Middle East for confidentiality. We have a project to predict the ultimate recovery. They call it estimate ultimate recovery, EUR. And we have so many data, and one of those data, it is geographical data, completion data, and reservoir data, and eventually we predicted the EUR. So machine learning, any domain where you have a data, you can make machine learning or deep learning project. It can be reservoir, it can be upstream refinery. Even this concept, we can apply it in health sector. If you have big data for a specific hospital, and they talk about the patient age and the gender of the patient and the location where the patient is coming from, and actually his disease diagnosis, and eventually will pass, will die. Machine learning also can, as a classification method, can be used to predict. It can also be used in the football domain, football sport, to predict win or lose based on historical data of a specific two football teams. So whenever you have a data, you can do machine learning or deep learning project.
Okay, we still have one questions. What is mean first principle from oil and gas perspective?
Okay, first principles. I believe most of the attendees, they are chemical engineer or petroleum engineer. First principles is actually the thermodynamics and physical chemistries we studied in university. How to apply the first law of thermodynamics, input minus outputs plus or minus rate equal accumulation. This is first principle. PV nRT, this is first principle. How to calculate the density, viscosity, based on the PVT of a specific component if I have a mixture. So we call this first principles. To simplify, HYSYS is a first principles. Petrosim is a first principles. PipeSim is a first principles. So this is the concept where we rely on the component, where we rely on the thermodynamic, where we rely on the science. In machine learning, we rely on mathematics, statistics. It is entirely two different concepts. Eventually, they help us to resolve problem, to come up with conclusion. Machine learning advantage and its edge on top of the first principles, it is very quick because no need to start from scratch to define component. If I have a reservoir problem or distillation column problem, no need to identify the assay and to identify the number of tray of the distillation column. Simply, I will get the operating condition and then I can conclude if I increased the rate to the crude distillation, how much yield I can get from the column. Very simple and very accurate. First principle is to apply the same problem, but to build this distillation column on HYSYS.
Okay.
Is that clear?
I think Engineer Manatalla, can you send
I would appreciate if people they can speak. This would be much better to facilitate and to streamline the communication. Keep in mind, people, there is no stupid question. Every question is a question, needs an answer. That's it.
Okay, guys, if you want to speak with the instructor, you can click on the raise hand button and we will unmute the microphone for you. Don't be shy. Okay, we have a question in the chat box. Celix MB has its own database for first principles or fit for purpose first principles are uploaded for each project.
Can you repeat I really prefer the guy who asked, who wrote the question, if he can speak up to understand his point.
Engineer Mustafa.
Hello.
Assalamu alaikum.
عليكم السلام دكاترة.
Yes, please.
What is the best tool used for data analysis in oil and gas? Is Python is the best tool for that?
Python is actually one dot in that broad map. You cannot say Python will give you everything. We SelectMB, it is already embedded with Python to use the library in Python, but you need to have so many visualizations. So Python will not give you that front end. It will give you back end, and you need to write very long and comprehensive code to eventually predict the R-square, Q-square for any problem you have. But at the moment, I would say there are many commercial packages similar to Python. Python is the most simplest tool, I would say, nowadays, and being used by most of people who are working and interested in data science and machine learning. Because Python is like MATLAB. MATLAB also does some data science and machine learning. In addition to that, in Python, you can do mathematical model. You can solve partial differential equations and ordinary differential equation, matrix, some algebraic equation. So it is an overall complete package. It depends on what purpose you need to use Python.
Okay, so in one project we can use different tools.
It is a good question, but it depends on the definition of the project. What is the scope and the objective of the project we talk about here?
I mean, in oil and gas, reservoir, or anything like that, generally.
Yes, if you talk about machine learning projects, you can use Python, definitely.
Okay, thank you.
Okay. Any other question before moving to the next slide? Okay, next, please. Okay, now since we talked about the what does it mean by machine learning, or what is the machine learning? It is an approach, and it gets the data from the field, and it creates correlation with an objective to come up with some prediction. So without machine learning, imagine if we have a problem, and one of the weaknesses, just to apply SWOT analysis, we talk about this reservoir model, or this distillation column, or if it is a reactor. Let's say it is a reactor, it is a black box model, it is a property, it is licensed unit operation, and I have no clue about the kinetics, rate, and the catalyst type, and the activation, deactivation of the catalyst. For me, it is a black box model. Overfitting, this is also one of the problem we face when we are getting the data. I may came across overfitting, which is actually misleading, and it will result in a very poor prediction. Data conditioning, it is another challenge. What techniques I need to apply? So many things to apply to clean the data and to understand the relationship between X and Y as a feature engineering. So this is one of the weaknesses. Not everyone in oil and gas who has a problem and would like to come up with a quick conclusion has this capability in terms of data science, machine learning, data visualization. And also one of the weaknesses of that model you will create, it is limited application. For the Python file you will come up with, it is specific for that unit operation. You cannot scale up this application to other application. So, and this is conventional approach I talked about. When we apply conventional machine learning to get a team for data science, another team for software development, and team from domain knowledge, it is 3 different domain and highly unlikely to find an overlap. We are getting this overlap by encapsulating and making overall frame to make sure all these 3 domains, they are working together through industrial AI commercial application. Next. So getting these features to link input and output, and to select the right algorithm, and to have clean and simple technology to do data conditioning and data fitting. Next, please, continue. So actually you are killing so many birds with one stone. In one application, you have very simple techniques. Just you are clicking the button, drag and drop. All that time you need to write a code, to validate a code, and to make sure this is the right code, you can do it as an application. And the outcome from application, it will turn these weaknesses into strength. Next. So as a deployed application, it is no need to have a programming. It is fast execution, high accuracy, easy to use as a framework. Our intention, we shouldn't turn into data scientists in the oil and gas. We need to understand the concept, and we need to be a very excellent user of the ongoing technology. We don't need to reinvent the wheel. To have a machine learning, or to have the capability to do a machine learning, the criticality and the agility of the project in my operating company will not wait me to master data science and machine learning. And I can tell you, there is no quick roadmap to be an excellent data science or machine learning. It is similar to how long it will take you to study chemical engineering or petroleum engineering. We talk about from 4 to 5 years worldwide. So it may take you from 2 to 3 years to perfect and to master the data science and machine learning. So relying on very quick courses and to learn Python in few weeks, this is not a machine learning. It gives you a recipe, but it is not the complete framework. It is exactly similar to how long it will take you, how many subjects, what are the subjects you need to study to be a qualified petroleum engineer and chemical engineer. So our intention from this series, we are sharing the knowledge, and we are giving you that skills to understand what does it mean by machine learning, how to apply machine learning, and when to use machine learning. And then you can rely on application. You need to complete steady state reservoir modeling. You have Eclipse. You don't need to reinvent the wheel and to do a programming from scratch to do Eclipse or similar software to Eclipse. Similar to HYSYS steady state, you don't need to invest more time to be an excellent programmer to do software similar to HYSYS and to prove yourself, I have done something similar to HYSYS. This is not value engineering. You need to understand how to define my problem. This is very important skill. After that, what kind of tool I need to use to resolve my problem, and then to be a super user for that tool XYZ to resolve my problem and to come up with solid conclusion to be shared with the management and C-level to eventually proceed with option A or B or C. So this is my key recommendation, key advices. No need to reinvent the wheel. Data science, because I have been through this process long time. Data science, it is not just a Udemy course for a few weeks and to be a data scientist or machine learning, a specialist engineer. It is more than that. People studies these things for a few years and they are still learning. So you became a petroleum engineer, chemical engineer, operation engineer with a very good domain knowledge. You need to understand actually the technologies in the market. You need to understand its component and then how to execute project using a specific tool. And this is why I presenting that specific slides, how to convert your weaknesses into strength. So eventually these applications, it can be another application, not necessarily Select MB. It can be, let's say we have another application that is called AI master. You need to understand the process at the back end of this AI master and how to use this as a steps. And then you can put things into perspective. Whenever you have a really challenge, I will use this application to give me my result. And you need to apply your thought process, your domain knowledge, and to read the outcome from that application or any other application. Next. One of the now we talked about what we have answered. What is machine learning and how to execute a machine learning project from that framework, starting from the plant data, first principle data, and the key steps. Now we talk about when and why. Why to use machine learning? When to use machine learning? This is another important question we need to understand this slide to say and to compare and to relate this experience to your operating company or the team you are working with. For that problem, I really need to use machine learning, or that problem really does not need machine learning. Some people, they are overselling machine learning and deep learning as if any problem in the world can be resolved by machine learning and deep learning. And I can tell you confidently, no. Machine learning, it is just a technique, similar to any technique. Some problems, it really need machine learning. Some problems, it can be resolved by using first principles and the conventional way of working we use on a daily basis. But we need to understand when and why to use machine learning. One of the key applications of machine learning to get a value proposition from it, the area of asset and facilities performance. If you have a specific facilities and you need to understand the performance of the adequacy and you have data, and some of the projects we call it from the project perspective, it is critical path project and we need to execute very quickly. We need to come up with decision. And this decision is very important to the decision maker to proceed with that project or to decline this opportunity. In either cases, it is very good for their revenue. Also, we need to agree the overall oil and gas industry, it is based on the profit, not just to satisfy our engineering ego and our capability. It is not about that. It is to make a profit. And all decision maker, and when you, inshallah, be promoted to be a decision maker in the soon future, you will be focusing on the target you need to achieve and the revenue. Yes, engineering capability, it will help you as a tool, as a decision maker, to say, yes, I need this or I do not need this. But at the same time, you need a tool to help you to come up with very accurate decision in a quick time. So if you have some with respect to the asset performance, can I use this separator for increase the production profile? Can I increase my refinery capacity on the crude distillation unit? I have a specific change in the operating temperature to that fired heater, and I need to know how much of fuel gas it will be consumed. And this fired heater, it is really complex as a geometry, and to model this in HTRI or EDR, it will take long time, and I need to make a decision. I need to get an answer in this week. And by the way, this is one of the real cases I have been through, and I'm very willing to demonstrate these cases in the next session. So for that case, you really need to have machine learning, providing if that facility in question, it has so many data. If it has data, it is a very good opportunity to apply AI project. If you don't have data, it is what it is, and you need to apply first principles project. Next. Another application, which is asset integrity and reliability, and it has already started, it has begun, and so many operators in Middle East and United Arab Emirates and Saudi Arabia, now they go to the soft sensor, and these soft sensors, because to replace the current sensors with a new one, it is capex intensive, and they need to have too much budget. And in the other hand, they have historical data for more than 15 years. Relying on this data, you can create soft sensors, and these sensors will give you the reading of the RVP, of viscosity, of the basic sediment and water in your crude oil. And machine learning will act as a soft sensor rather than to buy so many physical hardware. If you have good data from your field, you can apply asset integrity to establish soft sensor, and this would be the value proposition you can get from machine learning. Next. Predictive maintenance, and as discussed before, this is time forecasting, providing if, again, the key message here, preventive maintenance, it is every 6 months, for instance. Be that as it may, I'm going to maintain my exchanger every 6 months. Maybe in reality, your exchanger has potential to work extra 2 months. This is, by the way, it is a cost you have wasted because you didn't allow exchanger to continue those 2 months. And every shutdown, it is actually revenue cut, and you are spending on utilities, and these spendings during the turnaround and shutdown, it is not getting back to your pocket. So the rule of predictive maintenance is to turn the unplanned downtime into a planned downtime, which means your revenue will be much bigger, and overall profit, it will be quite high, respective to the preventive maintenance. And predictive maintenance can be achieved by machine learning time forecasting. Next. Functional safety, it has a great application, and this based on the, we can get data from the reliability handbook, Burida handbook, IGOP, and also we can generate data from ISA 84, for instance, to predict the probability of failure on demand. Each and every component in our industry, it has a probability to fail. And it is a figure, 0.2 per year, which means the probability to fail per year, it is 0.2. How many times? It can be 0.1 time. It can be 3 times. This is very essential to understand. And machine learning based on the data from the field and also in combination with the data from the statistical data, you can make a system, you can make an application, and this application can predict the PFD. And this PFD will help you too much when you have loop analysis, when you do cell determination and cell verification. At the moment in the industry, when it comes to the LUPA, it is semi-quantitative and it is 50-50. So 50%, it is based on the assumption. So converting this assumption into real data and real prediction, now we are converting the LUPA from semi-quantitative to quantitative, and this is very high value proposition you can get from machine learning as an input to the functional safety and HSE within your operating facilities. Next. So this diagram on the right-hand side, it can tell you, imagine the baseline is 100%, applying machine learning. And again, this may vary from one case to another case. This is based on real projects. Personally, I have participated in applying machine learning for problems which is related to the asset performance. You can get 75% as an additional value on top of the 100%. And for the asset integrity, to monetize the value acquired from the machine learning, it has estimated based on our projects of 90%. And similarly for the safety and functional safety, it is additional 60% on top of your baseline business. And this is how you can see as a quantified tangible value proposition you can get from a machine learning in various applications. Next. This is another slide here. I wanted to, you will not feel these numbers today, but in the next session, you will start to feel and to sense these values when we apply so many projects. But here, I talk about from the left-hand side, we talk upstream and midstream projects, operating company, application. It was asset and facilities performance, asset integrity and reliability. And based on the time saving and revenue saving, we talk about saving up to 1.6 million as a capex. Net present value improved by 8%. Profit margin improved more than $0.5 per barrel for the upstream. And all these monetization from AI being acquired by applying machine learning. Similarly, for the refining, we talk about reducing energy cost. And this is one key pillar. I believe most of you hear about the energy management system. One of the key indicator of the energy management system to have sound and integrated management system of your energy, you need to reduce the energy cost losses. And to do this, you need to have very good monitoring. And to do monitoring, if you can replace the faulty sensors with soft sensors by having machine learning prediction, this will improve the cost and it will reduce the cost. And at the same time, because it is three-legged race, if you optimize your energy expenses, your net present value will improve. So it is knock-on effect. It is like a chain. Once you enhance a specific dot in that chain, the other dots will be enhanced. And similarly for the condition-based management, applying the time forecasting. And this is the value you can get from the proactive predictive maintenance, which is you are still using the potential life within your facilities rather than stopping these facilities every 6 months or 9 months, even though it might have some room to continue to operate. Predictive maintenance will tell you you still have room to operate, and this itself, it is a big value. Undesirable event, and this is with the EPC engineering company, and this is about the reduced order model. And the reduced order model, in brief, I will talk about it in the next session. It is an old concept, but people started to regenerate and to rebirth the reduced order model in the light of the machine learning and deep learning application. Next. So this is the second and last part of today's session, and I need to walk you through quickly the Celix MB, what this software looks like, and what kind of steps you need to expect next time you will go through to apply a complete project. So before going to the demonstration, I hope we have covered the what question, how question, when question. Even though if anyone has a further question or doubt, something to be further explained, just ask me before starting the demonstration of the Celix MB. If no question, we can proceed.
Okay, we have one question in the chat box. What is the main hybrid model for from your perspective?
Okay. English-wise, hybrid, it means it is something works with two ideas. This is hybrid. It is like a burner. If you have a burner and this burner is working with fuel, gas, and diesel, it is hybrid. It works with two concepts. Hybrid here, we can execute machine learning project using real data from the field. And also, let's say life is not ideal in operating facilities, and you cannot get all data from the field. As a best case, you can get 90%, 95%, but you still need 5% of that data. How to do this? You need to create this data from first principles, from a simulation. So having the capability to get the data from first principles and to combine this data with data from the field, it is hybrid because you are introducing different types of data to your machine learning engine. So we call this hybrid project or hybrid machine learning. It is a terminology. We as an expert in industry, when we hear about hybrid, we understand it is not pure from the field. It is not pure from the first principle. It is a mix.
Okay, how to merge between physical model like thermo and fluid with ML model?
Oh, this is a great question. I can answer this next session. It is not meant. It was not meant to be in that session, but I can give an overall view about this. Imagine you have a distillation column, and the way we model this in HYSYS, to converge with the column, we need to provide the tray efficiency as an input, right? So this is an input, but in reality, tray efficiency, it varies. It is not static. You cannot find, you cannot see all trays in that column with the same efficiency. So going down, if efficiencies goes down, going up, efficiencies goes up, you have a gradient. So hybrid in that case, I will build my distillation column using first principles and maybe using mathematical model. I can write the model. Eventually, it is first principles. Whether it is written by you or you are using commercial software, you have a model. And you need to improve the model by predicting the tray efficiency. So you will get the data from the field. This data, it will be, you have all inlet flow goes to that distillation column, inlet pressure and temperature. This is reading from the field. And the yield from distillation column, you have that reading from the field. You will connect the data from the field. You will map out the process variables. You will link it, and you will apply sigmoid function, which is artificial neural network. And to inform your master engine, please make reconciliation between input and output with respect to the data from the field with an intention to predict the tray efficiency. So you have first principles, you improved the efficiency of your model utilizing the data from the field because it is actual reading and actual data. And the data backward, it will tell you to have a specific naphtha yield from that distillation column, a specific kerosene yield from that column at this inlet flow rate. definitely tray efficiency in that case, it has to be 65%. It is not 100%. So this is the key advantage you can get from hybrid model. And to have this link between data and thermodynamic. And also it has a great application in refinery reactor to predict the kinetic rate. Also you have reading for the reactor and inlet and outlet. You will model that, and rather than making an assumption to the input of the rate, you will let the sigmoid function and artificial neural network to predict the kinetic rate. And also we can do this for an exchanger to predict the overall heat transfer coefficient UA. And this will help you to also predict the temperature outlet as an indication, do you have a severe fouling or not? Is that clear?
Yes, we have another question. By MLR, we can modify any chemical engineering equations like Harney and EOS, etc.
By machine learning, can we modify what?
Any chemical engineering equations like Henry equations and EOS.
No. First principles is first principles concept. It remains unchanged until our day die. So PVNRT, it is PVNRT. Machine learning will not, again, reinvent the wheel of first principles. We agreed the AI concept, it gives the same function and the same objective as first principles, but in a very quick way. And also it can help you to understand the specific complexities within the system if you cannot model that system. We talk about reactor. I cannot model this because it is licensed to UOP or accents, but I have in and out. I can model in and out in AI to understand the kinetic rate of that model. But AI will not revisit and will not tell me, be careful, the equation you have been using for the last 50 years, it was not right, and the right one is so and so. This is not is going to happen, and it is not the function of AI.
Okay, we can apply this only for structured data, flat files, or can we use also unstructured data like sounds, alarms, images, locations?
You talk about image recognition.
I don't know. Islam asked this question.
If you can give an opportunity to Islam to speak up this question, I don't think I understood his question.
Okay. Engineer Islam, I give you a permission to open your microphone.
Hello, Assalamu alaikum.
Alaikum salam.
Mr. Emad, how are you? I just asked if we can import only structured data like flat files, as we are talking about Excel or HYSYS, or we can also import unstructured data like geospatial data, like images, like alarms, the sounds of the alarms. We can use machine learning for this kind of data, only structured data we can use or not?
Okay, if you talk about image recognition, this is computer vision, and yes, it is part of the machine learning to make image recognition. If you are training your model on a specific figure and configuration of pool fire, jet fire, flash fire to give you heads up, you can do this. But this is not the scope of SelexMB. SelexMB, we talk about the data from the DCS. It is CSV file. It is reading. It is numbers or categorical data. such as yes, no. So this is the scope of SelectMB at the moment. You can apply computer vision. There are also other commercial software where you can apply computer vision, the figures of fires. This is similar to, if to the best of my recollection, Pi Safety, which is courtesy of Kagera AI. They have this, they are leading in the process safety, and they have the capability to reprocess images to make a prediction as a warning to the field and to the site.
Yeah, got it. Thanks very much.
Anytime. So we can proceed with that quick demonstration. Next. Okay. So as I said, it is a SaaS application. It has a POUT, it has a contact, it has a sign in, and you can log in with your username and password to have an access to your own database. And in this database, you can have list of projects where you have executed within your teams and within your operating company. And we have an intention and partnership with SPE to empower this and to promote this with the students, to let them to apply these projects. And it can be one of the, very soon down the road in the future, one of the undergraduate project is to do machine learning project from A to Z. And also it can be one of the master degree projects, how to improve a specific prediction in a specific area. So we have an academic view with SPE to improve the capability and to spread this awareness among the academic students, undergraduates and postgraduates, to have this knowledge, to understand this technology and to master the use of this technology. Next. Next. So first thing you will see, it is very simple, 6 steps. You are importing the data. Second step, you identify your key performance indicators. Third step is to clean the data. Fourth is to build the model. And fifth, to validate the model and eventually to deploy the model. So first one, when you go to that import data, as you can see, choose the file. And this is simply, it is a template CSV file from the DCS. I can see there are so many people, they are coming from the field and they know the template, CSV template they can obtain from the DCS. And this is the same template where you can upload directly the process variables of interest for your case to start your machine learning projects and to complete your machine learning project. Next. Next. So here, if you don't have the template, here we have an option. You can download the template, and this template, it is a CSV, and it is a matter of copy and paste it from your data to the CSV. And this is, if we talk about offline solution, online solution, it can integrate with your simulator. Some companies, they use HISYS, Petrosim, Unisim. So the executed file also, it can integrate with those software. And if you have an online simulator running to your DCS, SelectMB eventually will read these process variables on a timely manner from your DCS, and it will make a timely based prediction. Next. Step number 2, identify the KPI. If you remember, when I talked about the framework, I said KPI definition is very crucial. If you fail to identify your key X and Y, your project highly likely will be screwed up. And really, this step number 2, it translates and it shapes up our domain knowledge into well-defined KPI. And our domain knowledge is really needed in this step. If you don't have the right knowledge of the operation facility, if you don't understand the PFD, P&ID's control philosophy, highly likely you will not able to define the step number 2. The concept is proven. Data science, machine learning, and deep learning, it is already proven 50 years ago. So it is a knowledge, it is a proven. If you are applying a project with a poor experience in oil and gas and you fail to define the KPI, it is not machine learning a problem. It is actually you have failed to identify this problem. And personally, I have a very good experience with Dr. Tariq. It was one of the postgraduate projects where we were examining various process parameters to predict the dead crude oil viscosity and density for various API sample. And we eventually found the recipe of the KPI. We selected two component, 2 parameter, 3 parameter to make so many permutation, parameter A with C, parameter A with B, all of them together. And we got so many different parameters and different prediction. And eventually we concluded a specific KPI. So this is what you need to do. If you lack the process experience, you need to get to this experience from someone else from the field. And as you can see on the right-hand side, the upper corner, one of the key requirements to satisfy this step, you need to have a process description. You need to know the process description, and you need to have the PFD, the P&ID control narrative, and field operation input. And on top of that, what is your problem? What you need to achieve from this one? The lower figure, it is a crude distillation unit, and it was a refinery in Middle East. We wanted to increase the production from a specific 1,000 barrel per day to another additional barrel per day, and simply wanted to predict the yield: naphtha, overhead naphtha, kerosene, light gas oil, heavy gas oil, and diesel. So these predictions will help us to determine the adequacy and inadequacy of the main column and the side stripper. So that was our key intention. And to satisfy this intention, as you can see in the KPI, we define the reflux ratio, feed flow rate input, naphtha rate, kerosene, diesel, atmospheric gas oil, residue flow from the bottom, and pump around. We have got 3 pump around loops, and eventually the WTI index of the crude. And after that, we determined what is input and what is output. The dependent here, it will be the process variables will be predicted by machine learning. So any change, and we selected the reflux ratio because in our P&ID, it used to have FIC. So one of the advices and recommendation based on many projects in the P&IDs, if you have a control loop, basic process control system, FIC for instance, so the reflux going back to the column, and you have a process reading for that reflux going to the column, it has to be independent because it is a set point in your system. You cannot predict what you control in your P&ID. It is a mismatch. So this is why I was referring to the P&ID as an input. Basic process control system will help you somehow to identify what is independent and what is dependent. Next. Then we can see in stage number 3, we have 4 nailed down embedded techniques. It actually it encapsulates all techniques in data science and feature engineering you need to get to know to help you to proceed further with that project. And by the way, feature engineering, it is really powerful. And based on the Spearman correlation you will get from step number 3, it can tell you your data is not a data for a machine learning. And then you can conclude this project cannot be a machine learning because of the quality of the data I got from the client. It is not up to scale. It means you may ask for more data. If he's giving to you 1 month data, you can ask for 3 or 6 months. And then you need to read the data and to read the Spearman correlation and the feature engineering to see the order of magnitude between the independent and dependent. If it is big order of magnitude, it means you can continue with that project. If it is not a machine learning. Next. So in data visualization, as you can see, it is very important, of course, to visualize the data, to see how the data varies with respect to the time or with respect to the number of breeding. For each and every process variables you have got from the CSV, it gives you an indication. And if we can zoom out, we can read very good statistics. We have minimum, maximum, average. Variation rate is very, very important. And based on experience, if you have variation rate lower than 7%, it means this data will adversely impact the accuracy of your model, which means you need to get more time for that process variable or to exclude it from your analysis, because variation rate of it is very, very low. Next. This is heat map. Personally, I really love to work with heat map to see the order of magnitude and whether it is it's proportionate directly or inversely. This is very important also to develop my intuition. As you can see, all the process variables we have got, it is laid out on the y-axis and x-axis, and it gives you a pairwise comparison from 0 to 1 and from 0 to -1. So based on the color gradient, you can get the color. And inside the application itself, when you hover at any square, it will give you the order of magnitude 0.1 or 0.5. And in some cases, it is -0.5. So as long as you are heading to 1 or -1, it means that the order of magnitude is very strong, and the influence between those two parameters are very strong, which means this is a very good indication for you as a precursor. This case is a reliable case for machine learning because you have strong bond between these relations. If the order of magnitude is very low, personally, I would recommend you to go back to step number 2 and to untick this process variable from your KPI. Next. This is another very good applied application of the feature engineering. As you can see, all the independent parameter, input parameter, it is on the y-axis, and this is for one dependent prediction, and it tell you that predicted variable. It's really very significant with all of the data except the dip, and this is for the up dip and down dip, one of the geological data of any reservoir. So that feature engineering and Spearman correlation, it can tell you the data I got for the dip, it is very low, and simply I can go to step number 2 and to untick dip, because having a small influence parameter within your database, within your project, it can lead to underfitting or overfitting, and this is something it is misleading and misconfusing to the machine learning. Feature engineering and heat map will help you to control the accuracy and the agility of your project. Next. Another way of data visualization you can get in step number 3, graphical presentation between X and Y from the CSV file, which is something nice to have to understand also the graphically the influence between X and Y. Next. Another very powerful tool, data slicing. If you need to slice a specific data based on your operational experience, yes, this data, it has an outliers and there is a noise. You can actually go to the data slice and simply you can drag the mouse to the right, to the left to slice out this unhealthy data, and automatically it will be removed from your data to have healthy data and healthy condition to continue your project. without in selection B, there is no need to write any single code. Next. Data check limitation, also very powerful tool, where in some cases we need to have this hybrid and synergy between first principles and machine learning. Machine learning, as I said, it is a statistical method, mathematical method. It will not understand maximum opening percentage of a valve cannot be more than 100%. So if you have a reading for a control valve and you need to make sure it is within the first principle, you can make a bound, you can clamp the reading of the prediction from selection B, minimum 0, maximum 100 for control valve opening. Next. Noise removal, it is automatic cleaning, and as you can see, the blue one, it is actually the clean data, and the orange one, it is the raw data from the field. And this is real cases for a specific fire heater from Middle East refinery. And we used selection B to automatically clean the noise from the data to have a better prediction from machine learning in step number 5. Next. And once you continue all the data slicing, cleaning, and you conclude step number 3, it will tell you the healthy data. Now you have moved 4% of the data which was already deemed unhealthy based on the data slicing and data noise removal. And what will continue with you in step number 4, 5, and 6 is 96% of the total data you got from the field. Next, please. Here in step number 4, simply you will provide the split training testing. The more you train the data, it is very good for prediction, 90%, 95%. And automatically, once you define the KPI, as you can see, all process has already featured automatically around this box. Reflux ratio, feed flow rate, and WTI as an input, and the predicted data, which is the objective and the scope of selection B to predict the naphtha rate, kilo, diesel, atmospheric gas oil, residue, and pump around rate of your distillation column. And from that drop-down menu, you can select any algorithm. Not necessarily to use the same algorithm for the same for all the outlets. This is our flexibility. You can use different algorithm because each algorithm has its own pros and cons, and you will get this from step number 5, which is validation. So what is already good for purpose for naphtha rate prediction, it may not fit kilo and diesel prediction. So this is why we have a long list of algorithm. You can use it, and you can make cross-examination in step number 5 to conclude the accuracy. Next. Once you made a prediction, as you can see, the parity plot, this is one good indication about the accuracy, measurement of accuracy and measurement of predictability of your application. And also we have a graphical presentation of the R-square and the Q-square. And simply you can see naphtha rate for that specific algorithm, it is 80%, which is not bad, but it is also not good. Residue flow rate, it is 90%, quite good. Atmospheric gas oil prediction, it is fairly okay. Diesel flow and kilo, they are not good at all, which means the algorithm I have selected in step number 4, it is not that optimum to have high accuracy for my crude distillation column. So you can go back to step number 4 and you can select another algorithm. And as you can see in the snapshot KPI, each algorithm you will select, it will be recorded as a snapshot, and you can go back to that snapshot to retrieve its characteristic and its fingerprint. Based on the selected snapshot, you can deploy your model. Next, please. So that was algorithm 1 selection. Algorithm 2 selection. As you can see, different algorithm, snapshots, different snapshot. We can see 100% very accurate prediction for all outcome from the crude distillation column. And as you can see, the parity plot, it is almost all the points, observed data and predicted data, it is around that 45-degree line, which means it is 100% R square and Q square. If you are satisfied, of course, with that one, you can select the snapshot and you can proceed further to deploy the model. Next. So this is, as you can see, different snapshot and different parity plot for snapshot 0 and snapshot 1. It is very simple way and a nice way to see the differences between various algorithms. Eventually, you can select the most highest R squared and Q squared for further deployment to complete that project. Next. The same comparison in a graphical way for the same unit operation to understand the performance of that crude distillation unit. Next. Here, this is the last step. Now we are deploying the model. We can input a specific reading, actually the business case. I have this reading from the planning department and how much additional feed they need to add. And eventually the model will predict the additional increased expected rate to the naphtha, kero, diesel, atmospheric gas, oil, and residue. So it is very good input if you have what-if analysis. It can also fit hazard purpose and loop purpose, ad hoc basis study, capacity, increase check. Next. So I think I have come to an end of that presentation, and we can now conclude from the previous step number 6. The model is deployed. Model is selected firstly based on the most highest R squared and the Q squared, and now the model is ready to be used by any team member within the organization, even technician who has no experience with first principles, no experience with machine learning, but he got to the operational experience he needs to examine a specific scenario to report the key outcome from that, selects MB to the management. These are the perceived additional capacity as per my data sheet. Side stripper can accommodate, other stripper cannot accommodate. Maybe for the other stripper, we need to have a specific detailed engineering to check its capacity. So this is the real power and advantage of machine learning. Even if you have a scope, no need to give the entire scope to an EPC. You can get a specific scope from that one based on the outcome from the machine learning, based on real data. So it is significant decrease in the engineering time. And from the money perspective, you don't need to give 100% of the entire scope to an EPC. You can select actually the bottleneck in the system based on the flag and warning from machine learning. And the contractor will do the conventional engineering to tell you what kind of side stripper, new side stripper you can get to comply with the additional flow rate. So thanks for your listening and your time, and I hope first session was quite fruitful, and the questions related to the what, how, why, when for the machine learning, it is well understood, and hopefully the next sessions, it will be more practice, not basics and fundamentals, and I will try to make sure to diversify the problems. One problem which is related to the reservoir prediction, flow assurance, pipeline, distillation column, reactors, petrochemicals, to give very good perspective and diverse for all of you about different cases where we can use machine learning. Also, we'll try to include predictive maintenance as use case to practice together in the next sessions. I think before conclude, If anyone has any question regarding that second part of Selix MB demonstration, feel free to ask before concluding the meeting.
Assalamu alaikum.
Wa alaikum salam.
Can we use Selix MB integrated with any one of the commercial CMMS systems in the market to improve our predictive maintenance strategy, or we should import the data as a
Muhammad, if you can repeat, your voice is a little bit breaking.
Sorry, the coverage. Okay, can we use an integrated form of data between the commercial CMMS systems in the market and the Selix MP?
Commercial CC again, please. Stand for what?
For the maintenance,
Okay.
like SAP and Oracle and Maximo.
Okay.
So we should import the data as a CSV file, then feed this to Selix MB, or we could integrate between them and the data is transferred at a real time, like between the historian or HISIS or Unisim or the file system.
With historian, you can do this through HISIS, and Selix MB integrates with HISIS. I'm not familiar, to be honest, with SAP application, but based on my shallow experience, it is a database. And this database, you can get it from your historian or DCS. It is a time-based reading, right, for a specific temperatures, flows, vibration for a compressor to predict the performance or any upcoming anomalies within your system. So simply this CSV, you can get it, which is CSV file from your system. In that particular case, no need to integrate with SAP, because you can get the file immediately from your DCS, and eventually it will predict the performance of your operating facilities in the upcoming month or months or quarter based on your plan.
Okay. So this should be a two-step. Import the CSV file and then feed this to the Selix MP.
Yes, true. Yes.
Okay.
And if you have a plant data online solution within HISIS, so it became one step.
Okay. Yeah. Thank you.
Other question?
Okay, at the end, thank you so much for Engineer Emad Elgebesy, the founder of Optimized Global Solution Company, and the next, inshallah, the second session will be at the same time in the next week. Thank you.
Thank you all, and see you next week, inshallah. Have a good day.
Inshallah.
Bye.
Inshallah. Thank you.